Hello class, welcome to your first lesson in grade 11 University Math. Here we have today 1.0, getting started, and we're reviewing the lines and parabolas. First of all, remember when we have equation of the line, it's usually in the form of y equals mx plus b, which is right here, okay? Remember that the two important things of the equation of the line is the slope, which is your m, and your y-intercept, which is your b. Quite often you're going to see the example of y equals 5x plus 4. What does that mean? That means that it has a y-intercept of 4 and a slope of 5. Okay? When you're asked to find the slope of 2 points, we will be using the equation y2 subtract y1 over x2 subtract x1. That's the equation here. Let's take a look at a graph. Here we have an example, y equals negative 2/3 x plus 5. Remember, that's the equation of the line, y equals mx plus b. From that information, we can see that the b equals 5 and the m equals negative 2/3. In order to plot that, ladies and gentlemen, you start at the y-intercept here, which is 5, and then you apply your step pattern, which means every time you start here, you're going to go down 2 over 1, down 2 over 1, down 2, down 2 over 3, make a dot, down 2 over 3, make a dot, and then you create your line. Okay? Looking at the second example here, it is kind of like in standard form, okay? It is not in the form y equals mx plus b, it is in ax plus by plus c equals 0. There are two ways to approach this question. Number one is to find the x and y intercepts. How do I look when to do the x and y intercepts? I see if the coefficients in front of x and y equally divide into the constant term, and in fact they do. So looking at example B right here, ladies and gentlemen, I'm going to show you how to use x and y intercepts. To find the x-intercept, you let y equal 0. So you rewrite this equation wherever you see a y, you put a 0. So 4x times 2 times 0 equals 12. 0 times anything is 0. So we end up with 4x equals 12. To get x by itself, you divide both sides by 4, so x equals 3. And again, that's a point that you can plot on the graph. X equals 3 is right here. To find your y-intercept, we let x equal 0. So again, you substitute it in. Wherever you see an x, you put a 0. Simplify this expression to solve for y, and you have y equals 6. And again, you plot that on your graph, and then you have the line. Just a side note, ladies and gentlemen, where the two lines intersect, right here where I draw some more happy faces, that's called the point of intersection. Good. Okay? And then remember, for proper communication on your graph, make sure you've got your x and your y-axes labeled, and that each equation is labeled either by the original equation or by your new substituted equation. Okay? Now let's take a look at quadratic functions. Quadratic functions have a parabola on the graph, and in grade 10 we had the equation y equals a bracket x minus p squared plus q. But we're going to find in this textbook in this year that vertex PQ just becomes h and k. Okay? So again, vertex last year was PQ. This year it's going to become h and k, and eventually it will change to d and c. Remember that we have a value tells us the vertical stretch or compression. So if the absolute value of a, this means to disregard the sign, just look at the number value. If it's greater than 1, we're going to have a stretch. And if it's less than 1, like a fraction 1/2 or a decimal 0.75, then it's going to compress. A also tells us the direction of opening. The direction of opening is going to be up if it is greater than 1, and it's going to be, or positive, and it's going to be open down if a is negative. And remember, your step pattern is a times 1, 3, and 5. P, which is another value, it tells us the horizontal movement, how we shift left or right. So if P is greater than 0, we're going to move right. Although, take a look here, folks, it looks negative in the equation, but the negative part is part of the formula. So if I go back up here to the original equation, notice here, guys, how the negative is part of the formula. So in fact, in this case, P equals 5, and that tells us to go right 5. Whereas if P is less than 0, we're going to move left. And i.e., that means when you look at the expression, it's a positive here. Take a look, guys. How did the formula that originally was negative get to a positive? A negative times a negative produces a positive. So that's why it tells us that we're going to go left. So backwards are the opposite of what you see inside the brackets. And Q, which is our last variable in that equation, tells us the vertical movement. If Q is greater than 0, it moves up. And if Q is less than 0, it moves down. Okay, and just recall the step pattern is A times 1, 3, 5, which means as you go over 1, you go up 1 times A. When you go over 1, you go up 3 times A, and over 1, up 3 times A. So whatever the value of A is, that's going to help us with the step pattern. And this will go either in the left direction or the right direction from the vertex because it's a symmetry point there. So you can go either left or right. Let's take a look at some transformations. So we always take transformations based on our basic parabola, which is y equals x squared, and we compare it to the new expression here, which is y equals negative 1/2 x plus 3 squared plus 7. Again, we look here and we say, hey, what's our A factor? So in this case, A is negative 1/2. The negative tells us it opens down, and in this textbook, they're going to say reflects the x-axis. And you need to use x-axis because later on we're going to be reflecting the y-axis. So make sure you develop that terminology that it reflects the x-axis, okay? And the half itself is less, the absolute value of A in this case is 1/2, so that means it's going to get wider. So you're flattening out this parabola, okay? Looking at the expression P is negative 3, that means you go left 3, and Q is 7, which means you go up 7. That describes the transformation. So again, to describe the transformations, identify what A, P, and Q are, and tell me what each of those represents in terms of a transformation. Then to graph it, ladies and gentlemen, we start with our vertex, which is negative 3 and 7, so we plot that point right here, and then we're going to develop the step patterning for this. Remember here, folks, that the step pattern is A times 1, 3, 5, and in this case, A is negative 1/2. So you multiply negative 1/2 times 1, 3, 5, and you get negative 1/2, negative 3 over 2, and negative 5 over 2. So from your vertex on the graph, come up here again. As we go over 1, we're going to go down 1/2, right here. As we go over 1, we're going to go down 1.5, and as we go over 1, we're going to go down 2.5. And you do the same in the other direction. Over 1, down 1/2. Over 1, down 1.5. Over 1, down 2.5. And then you draw your quadratic. Turning to the next page, we're going to take a look at some definitions. A parent function is the simplest form of a function, and we call that the base function. So given this example here, ladies and gentlemen, you should recognize this from grade 10. Okay? This is the quadratic. So what's the easiest form of the quadratic, or the parent function for that, is y equals x squared. Next definition we're looking at is absolute value. You will see this a lot during this course. It's written as 2 bars surrounding x, describes the distance of x from 0. Y equals the absolute value of x means make x positive. So here in some examples, the absolute value of negative 8 is 8, and the absolute value of 8, or positive 8, equals 8. All we do, ladies and gentlemen, is remove the sign if it happens to be negative. It will always stay positive. Okay? And the last definition we're going to take a look at today is called an asymptote. An asymptote is a line that the graph of a relation gets closer and closer to, but never touches or crosses. In these diagrams, ladies and gentlemen, it's the dotted line, not the actual solid graph itself. So for a hyperbola, ladies and gentlemen, the graph is the blue line. However, the asymptote are the black dotted lines here, okay? And those black dotted lines are where the relation approaches closer and closer, but never actually will touch or cross. In the example of an exponential curve, you will see here this blue dotted line takes the curve, which comes down here, and it gets closer and closer and closer, but will never cross or touch. So, ladies and gentlemen, that's our first lesson of this course, and our homework today is on page 2, number 4, 6, and 7. Please see me in class if you need any help.